Okay, yeah, so let's start cleaning up more of this, so get rid of this. And we could also indent, so we know like where this comment was extracted from. And 2 default shaders only, yeah, that's fine to keep that little comment at the top. And I don't know, something about like anchoring it like that I kind of like. So let's could actually do that. Okay. I'm good with that. That looks for just kind of cleaning this up. So let's close this .frag thing. And we have another data file. Let's look at that. So we have some more stuff. Let's open up our clipboard stack and just try to GRAQUAD.D. So we're going to open up the clipboard stack, and we're just going to take all these, all of these values. So this TD, are those undefined at the end? Because that's kind of like... So this is a lot of stuff where it's like, I don't know if it makes sense to take all this or not, but let's just, so we have like a fragment and vertex shader source, and then we have some of this just macro nonsense that I got carried away with in some other libraries where I think it was just a bad idea. And really that kind of stuff should be kind of refactored out, because it's going to make it really hard to find certain places where I'm actually using these functions. So let's just do CS dump. And yeah, so we got a lot of like really what this is public. And this looks like these are kind of like private variables. So right, we have like a nice little list of like all the things that are in here, and it'll give us an idea of what this is all about. But really, the only thing that I think we want to really care about is actually this. So we're gonna put this little list at the beginning because this is really what we care about. I think all this other stuff is just kind of noise, but we'll keep it in the documentation section just to keep a nice little index of all the different things that are in there, right? So now let's scroll it back to the top, and we have this little comment. So this is... Okay, so we have this this header comment in two places. So we want to take this header comment for the gradient quad and put it in the summary. And yeah, okay, cool. So yeah, in the summary, we're going to take that and we're going to put that detail in our summary section. Because we have this cut and pasted in two places, so let's just isolate it into the summary section, right? Okay, so now that we have this kind of, this isolated, and we know kind of like where it came from originally, we can take these comments out, and we can just make a little comment here of what this file is. So this is GRAQUAD.d._, right? And, you know, we can just leave it like that. And then over here, same thing. We can just go, you know, GRAQUAD.f._. So we have this refactor note. Is that also here? No. So we kind of already have this note here in our hashtag comments somewhere. I swear I saw this, or maybe... So let's go Control F and do gleb swin, right? Because that's where this came from. Oh, I don't see it, so maybe I just forgot to put the refactor note here. So, quad came from so we'll just make a note here of where this came from. And we'll take we'll say this was extracted from GRAQUAD.f._, date, or on date, 2020 12:05, right? And then we can take this refactor note thing and we can just get rid of this extra stuff, right? So with that, do we have functions? We got functions, so we still got to look at functions. So we're going to take this function file, we're going to put it over here, functions on the right. And let's go into the function documentation and activate our clipboard stack and just start taking different function names out of here that are important to us. So the halt function, halt or status, okay, that's interesting. On window resize, probably something that we don't want to use anymore. init data, error check, compile a shader, check the program, reclaim memory, open GL shader stuff, create the shaders, create shader code, junk code, error check, other lib data, whatever. Use that program. GL gen buffer, so it's like a wrapper for GL gen buffers. Yeah, GL bind buffer. And GL buffer data, right? So I just tried to name the functions based on what I was using them for, I believe, right? Because they're just all... They're taking the data and calling it, so it's like a side effect kind of function. I don't know if that's a good way to do it, but that's the way we've done it. So okay, so we'll take all those and then we'll just go cs dump and we'll dump that all in here. And now you have this list, and we'll take out the we'll take off the prefixes. And wrappers with side effects that you did we, hold on. So I seem to not be paying attention. I just kind of stopped here, but, there's more here. So quad setup, yeah, I don't know why the hell I stopped. Wait, we're inside of a function right here, are we not? Yeah, this is inside of loop tick. So hold on, I'm gonna stop here and I'm gonna just do CS dump here for a second. And anything after loop tick doesn't count here. Okay, so, this is just things we don't want to do. High level setup. So how is compile shader actually working here? Seems kind of weird that high-level functions are somehow at top without forward declarations. Because okay, wrappers, right, so we'll just organize that. Shader uniforms. Okay. So that's a lot of stuff, but it's nice to have just an index, an inventory of what's going on there. And with that, we have data documentation. And we have function documentation. So with that, we can kind of like move on to the next thing, right? So we'll close this. We will also close this. And then once again, we're going to do a sanity check. Make absolutely sure that as we've messed around here, that we haven't accidentally done some type of destructive refactoring, right? Okay. So it looks like we're good for now. Okay, yeah, I'd say we're good. So let's keep on moving. And we're going to see what's next on our list. So we see we have this free spot. That's literally a free spot. It means there's nothing there anymore. As we shuffle things around, I got annoyed about, having to shift everything. Like if we insert a library into here, right? Now we have to make this library number 8, and then we have to shift all of these up, right? And then we have to just rearrange a whole bunch of code. So I'm like, you know what? I'm not going to deal with it. We're just going to call it a free spot for now. It may be eventually, if we need a library that goes between GRAQUAD and FragBed, then we can just put it in the free spot. Chances are the free spot will never be used, but it's just me being lazy and being like, screw that. Let's just keep going and not waste our time shifting things around. So we could actually do that more often, right? We could start to do it where we could keep it where from now on we could just say that only odd numbers are we could say that only odd numbers are going to be populated from now on, right? So the next time I add something here, I'll add a free spot. 16 will be a free spot, and then 17 will be the next actual library. And that'll give us some breathing room for if we need to actually shuffle things around or make an insertion later, we can see that. And it'll also be it'll be much more obvious if we've made at least one insertion into things as we build upon the project, right? We won't be able to see all insertions because, because we will, we'll only have one spot for one insertion, but at least we'll be able to see where we had some redesigning and having to go back, right? Because ideally we just want to keep on marching forward and we want to layer things on top of each other, but every once in a while you come across a point where you can't do that. You got to look back and create some type of library that needed to exist in the past that doesn't actually exist, and so that's when you got to do that insertion of another library, and that can wreck your day a bit and be a administrative nightmare. But like I said, I would rather have my code be clear and dead simple than flexible. So I'm going to deal with that frustration because it allows my code to be dead simple, right? And even though it's frustrating to work with and it makes the code a little bit frustrating to rework and reorganize, the task of actually reorganizing it is actually it's not hard. It's just annoying and time consuming, right? And I would rather have annoying and time consuming than something that is complicated and hard to follow. So we have to pick our trade-offs here, right? So FragBed is the next thing. Let's go into there and see what we got. So lib frag or not FragBed. Okay, so we'll open up both of these. We'll put the functions on the other side. Okay. And we see there's already a nice big comment here, and so this is a nice summary as to what FragBed does, so I think that this actually belongs in the summaries. So it is pretty long, but the thing is that these summaries kind of have to talk about, what the thing does, right? So, okay, yeah, so we're going to just put that in here, right? So in our summary, we're going to put FragBed, and we're going to load this into here. And then, why the fuck did I do that backwards? So we're going to take these, paste. And then we're going to take the summary here. And we're just going to paste it right here. And then we're going to rework it a little bit. Because obviously we don't have as much room anymore, right? So if we indent, though, we're going to indent. And if we get rid of all the comment characters that are all around it, it looks like we actually will have enough room. And we can get rid of the underscore. We can get rid of that. We can just say fragment shader testbed. Right. Fragment shader testbed. We might want to say fragment. Right, like that might be easier to read. Okay. So let's read this for a second. Fragment shader testbed sets up 9 default shaders that serialize themselves to the hard disk. Shaders can be overwritten by opening the serialized to disk shaders. I'm going to put this in brackets here so that I know that this is one concept so that it reads a little bit better for me. Okay, I'm going to read that again. Sets up 9 default shaders that serialize themselves to the hard disk. Shaders can be overwritten by opening the serialized to disk shaders in text editor and editing them. Okay, good for me. On startup, we'll check for existence of serialized files. And we don't need to indent that. We have enough room. Oh, we have just enough room. If serialized file exists, contents of those files used as shader code. If serialized files do not exist, loads the shader code from the executable, saves the executable shader code to .frag files on disk. If mix of both, some serialized, some not. Files that are on disk are loaded from disk. Files that are missing from disk are loaded from exe. All exe loaded files are serialized to disk. So, so there's some other details here about how I do this kind of consistently. So to make sure that our function pointers to the code make sense, we actually have to copy the function pointers. If the... How do I say this? A function pointer to malloc memory is different than a data pointer to malloc memory is different than a data pointer to a hard-coded string in your source code. One pointer is freeable while the other pointer is not freeable, right? And we have a mix. We have a mix of shader code that may be embedded into the executable in the .text section of the executable source code, or it could be a malloc string that came from the hard disk, right? And so we don't want to make a mistake of where we try to free memory that is hard-coded, right? We have these non-freeable pointers. So in order to get rid of that freeable pointer problem, I decided that if we're taking code from the executable, we're going to make a copy of that code and put it into malloc memory. So that way all of our pointers are uniform and we don't have any problems with that. So we should make a note there. So I'm gonna take this and make a comment here because I don't know if that is where it needs to be or not. And then oh wait. Oh, so we already have this design note here. So what we're going to do is we're going to paste this here. Right? And it's really these design notes. So we're going to take these design notes here. So we already did make a commentary on that. And it's good we did because it was a very important design consideration. I'm trying to make everything as uniform as possible. The more uniformity in how we write our code and how the code executes, the less problems we're going to have in the future. So uniform, we're going to take this commentary right here and these design notes, and we're going to just paste these here. And we can make a note of where this was extracted from, right? fragbed.d._, on date 2020 12/15, right? Okay, now that we have this, right, and then we have fragbed freeable pointers over here. That's good. And we can just keep this here. We're not going to worry about what that's called. And we can keep this little design note up here. That's fine. Yeah, and we can, I think it's just a very important design consideration, so I'm also going to put this up here as well. It's an important design consideration, so let's have that little note in both of them. Okay, now let's look at the data and look at our data documentation, right? So, we'll do, over here, we're going to do a, we're going to create a section for the fragbed data documentation. And we'll also take this, while we're at it, let's just take what we've written here. And down here, let's create the same thing for the inevitable function documentation that we'll be doing. Okay, in here, let's just say copy, 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 copy. I think we could probably just get away with doing it like this. Well, actually, no, I'm not going to do that because, Notepad++ kind of has some intelligence about knowing if things were copied with a selection format like that or not. And so I don't want to pollute my clipboard in that way because I could potentially just end up with some weird artifact type things. So we're not going to do that. So I see that this is a big comment section. Okay, this is a note on what we're not going to do. And it's at the bottom of the file anyways, so I'm just going to keep this comment in here for now. In this, instead of extract it, I'm going to just keep it here. And let's do a CS dump of all of these stuff we just took. And then let's get rid of the so AAC20, so this is kind of like a pattern breaker. So we're going to just keep it like that. We're going to keep the full namespace for this one just because it's a pattern breaker, so we just want to make a note of it, you know? We want to... Okay, and then what's the default 001 versus the loaded pointer? Const. Okay, got ya. So these right here are non-freeable pointers, right? Yes, it even says loaded into RAM. So if we look at where like one of these is used, so we're gonna find in files, we're just gonna find all really quick, and we're gonna look at the usage. Yeah, so it's the default. It is the in hard coded. Sometimes I find that using backslashes or slash characters in a multi-line comment can be bad. I mean, this is documentation, so it doesn't really matter. But .text section hard-coded into .exe file, not freeable. Unfreeable pointers. So these are the unfreeable pointers, and then we're going to these may be loaded from, these might be loaded from RAM, or they're copies of the defaults, right? So we can make a note of that as well. Copies from .text section, or copied from disk. So let's just make this kind of symmetrical. Not freeable pointers are freeable pointers. And then the next thing we could do is we could try to get this aligned a little bit better, right? And just have like a little bit more just uniformity there in the commentary. Hold on. And then the next thing is all default shaders are malloc copied, right? That's just a comment thing that lets me know that all the shaders have been malloc copied. That's just a piece of state to let me know what's going on. So right here, okay. Good enough for me. Okay, so that's a nice little review of what's going on there. And so I think that is helpful. Now, I see that we have like FDS001, and if we open this up, we can see that we have all of these other things, and they're in lib slash... so this does count as data. So the other thing is we might want to put that list here. So in... right, and we can just do FDS001 dot. Right, that's all we have, right? We just have 0 through 9. We might want to just make a note of this. We might want to section it off in a way that it's a little bit more obvious that that this is a section for just this information, right? That way we know it's not. We know that it's kind of found in these default shaders, that it's this stuff. And when we open up FDS001, we get, right, we get these defaults. Now it looks like we already have the notes here. Oh, but we did extern, right? That's why we're seeing extern here. So we could do... I don't really feel like... yeah, that's breaking my indentation, but I want to make it obvious that these are externs, and I don't really want to, like, push this all over one more level of indentation and then have to worry about that kind of formatting. Or actually, I'd have to push it, like, over, like, this much, and then we have a whole bunch of difficulties with the formatting. So we're just going to plug on extern right here, which kind of makes it a little bit wonky. But it is important that we know these are externs, so that when we are... looking at these, you kind of know that they are in a different place, right? These defaults. Yeah. Might not be the best way, but I think that is, yeah. So this is kind of wonky the way we've done this, but as my grandfather says, perfection is the enemy of progress. So let's not worry about that too much. So this is the data documentation, which means the next thing we need to do is look at the function documentation. And just create, we can just create a kind of a list of everything that's in here, which will give us a good overview of what's going on, right? I'm going to copy this just in case I forgot it, because it's an important function. We don't want to miss it. Okay, so let's just do cs dump, And we'll delete the second instance of this if it appeared twice. Okay, yep. And then we will indent this. We'll remove whether or not it's public or private in the namespacing. And copy hard-coded shader strings, load file if exists, save text file to disk, simple key handler, and init. So noting that there's key handling in there is actually nice to remember. And with that, I think we're done here. Yeah, so we can move on, and so we can close this. And we can close this, and let's, once again, we're going to have a sanity check. Make sure that as we have done what should just be a trivial refactoring, make sure we didn't break anything. And once again, that's because I don't really believe in a trivial refactor. I think there's always the possibility when you are editing the code, even if you're just editing the comments, there's still the possibility that you could have unwittingly changed some code. So it still looks good, and I mean that's not the best test, right? Just to see if it compiles. I mean, I do have test code in there, but it might not have the best coverage, right? So, but it gives me a little bit of sanity of mind to be like, okay, I think things are good enough. Let's keep on moving forward, right? And now we are on GPU data, which I believe we already kind of did some documentation for, GPU data and pix name. So let's actually look at that. So in our function stuff, GPU data, we have halt and init. And over here, in our GPU data, so yeah, we did kind of like some documentation for this, and then GPU data paint5D is not here. So let's, for the sake of, yeah, because when we were refactoring this earlier, we were not going in order. And then I'm like, okay, let's just 100% this and do everything in order, right? So in GPU data, let's take a look at it. We may have already handled it, but let's just take a look at them and open them and see what we think, and see if maybe things should be kind of reorganized or not. So we have this big warning thing. Instances of AAC2020 GPU data do not belong in GPUdata.d or GPUdata.h. And that is actually a very important fact, that GPU data is going to be for different instances of different chunks of memory, and GPU data is this like generic thing, right? And so that's actually an important consideration that I do want to I want to keep this warning here. It's very important. So because it's an important warning, I'm not going to offboard this comment somewhere else, because it's something I absolutely want people to see, right? So I'm going to prioritize it, say, yeah, this is important. Yep, it's duplicated. It's in both of these, but it's very important. So, okay, so yeah, these are nice little summaries, I think. So we're going to... Do we want this Control F kind of help? Because this is... I don't know. So I'm guessing if I use this, I can just find things where it is, right? Oh, okay, no, it's, okay, I see why that's here. This is here, so you can find this class when doing grep on paint5D dot whatever the fuck. Do not extract. Okay, so this is kind of messy, but you know what? I do see why I have this. It's we want to make sure that the code can be followed. We want to. The hardest part is connecting all the dots, and this is just to help us connect the dots because these things are not actually in this file anywhere, but it's related to this, right? Because Paint5D is an instance of GPU data, so this is just to help us end up back here and know that that's relevant. So these summaries, let's take these summaries. And yeah, let's take these summaries and put them in the correct sections. And there's two summaries actually, because there is a summary for the data, and then there's a summary for the data file and so GPU data, right? There's actually a summary for the data file and a different summary for the function file, which is atypical from how we've been doing this. So we might want to make a note that we definitely want to make a note that D and F are they do different things, right? It's not like the, yeah. No. Okay, we can get rid of that C more, though. We don't have to have two of those things here. And we could kind of...
So you got
that one and
two
this one.
headboards?
Yeah, that's
You
it.
have the other pieces?
Yeah, they're already burned.
Okay. So now we've kind of offboarded all of that chatter to our summary file. But we can keep these warning messages kind of where they are. And this is looking much cleaner. As we go further into history, as we kind of go further down the chain in the project, right, we're getting to newer and newer code. And you can see that the style has kind of evolved. And I've developed a kind of a little bit cleaner of a style. Wow, I have that warning everywhere, don't I? I mean, it's important. It's really important to note, so I'm not going to get rid of it. I do want to make a little note right up here. GPU data.d._. And this one is GPU data.f._. Okay, yeah, that is good for me. Now, let's, before we do functions, let's do the data. So let's actually build the index of... Oh, got ya. So, oh, that's explaining the variable. I mean, that's fine. Oh, this is Paint5D. Hold on. Okay, so we could do that. Okay, yeah, that looks... Yeah, I'm happy with that. Let's go and look at... Yeah, let's look at the functions and see what we have for... we have nothing for GPU data for the functions, so I don't know if we just kind of forgot it. GPU data. Or that might have been when I got tired and I was like sick of this and I just left, because I think my food might have went... my food might have been done cooking and I was just like, out of here. I'm gonna guess that's probably what happened from yesterday. So let's open up the clipboard stack. And let's just start taking some of this stuff. So this, just take the functions, take whatever it is, if it's in the data file. Then we're just gonna take things that will give us a little summary of what is going on. That's the most important thing. Yep. Okay, and I'd say with that we can close this. I'm not going to worry about extracting some of these comments. Yeah, I'm not going to extract those right now. I'm going to keep on moving on. And let's make sure that this still compiles. Okay, it still compiles. Okay, we're good. Let's look at what's next. So if we take a look at our library chain, we're now on pixname. So if we go into our summary, we see GPU data, pixname, and it has a do one thing well summary already. And let's look at the data summary. So yeah, so pixname is missing from here. Now, yeah, so let's, it should definitely have some variables associated with. So pixname, and let's create a section for that in our documentation. And then in our functions, do we have a pixname? Nope, we're also missing pixname here as well. And is it pixname between GPU data and GPU data paint5D? Because I think that would actually be wrong. Oh, I guess we did it like that. Yeah, because... Is that the best way to do it? I don't know. I'm fine with that. That's fine. We want it we want these pixel names kind of close to where their usage is. And so the first time that it's used here. This could exist before GPU data. Technically, pixname could exist like way over here, right? Because it's not really it's not dependent on anything else. But we want to keep this linear order, and we want to try to keep things close to where they're used. So even though there's many different places where we could potentially put this, we want to put it close to where it's used, and we also want to try to maintain the linear order of when we came up with certain names in certain sub-libraries, right? So that's fine being there. I just wanted to make sure that kind of made sense. And so yeah, pixname is between GPU data and GPU data paint5D. Okay, and now that we have that, let's actually look at the functions and whatnot. So in our library, we can look at pixname, and I believe pixname only has data. It doesn't have functions, if I remember correctly. I could be wrong. And let's take, I was totally wrong. So let's look at the, so here's the data. And if we look at the data summary, do we have a data summary? No, we don't. So let's start collecting all the data points for this class. And we'll just copy, 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 and then just CS dump. And now we have this list of, right, there's obvious, so one is the names and one is an associated texture slot, and there's a reason for that. I just want to keep everything similar. It's kind of weird that the texture slots are here, but I just want some tight coupling there. Let's look at the functions and kind of collect what functions are here. That's not going to work. Okay, this one, an init function, that's all we got. Okay, so CS dump. We just have a halt function and an init function. So bare bones, simple stuff. I think I said that it was basically empty, and even though there's all this chatter, it is basically empty. It just has a halt and an init function. So we can close this now, and we can look at what's next. So we look at our library chain, and we're on the last thing, Paint5D. So let's open up the Paint5D. Oh, because it's called GPU data Paint5D. So that is kind of why, like, I'm this GPU data underscore Paint5D. I'm kind of thinking it was a bad idea. I kind of know why we did it that way, but I think it's just giving us headaches and making the code harder to follow. I do know that, you know, we wanted Paint5D to be like tightly coupled with GPU data, and so that's the way we did it that way, just to keep that association. But I feel like it makes our code more irregular, right? This is like a pattern breaker, and it's kind of, I'm getting kind of sick of it. Right, that little bump where it made it hard for me to find the thing, that will be exacerbated if you are new to the code base. So if it's a minor inconvenience to me, you know, it's going to be exponentially more of an inconvenience to someone not familiar with the code. So I think that it would be better to refactor that out now than later. So I think once we do the documentation here, we're going to refactor everything to just be Paint5D, right? And if Paint5D somehow needs more than one associated source file with it, you know, we can put that irregularity into the library chain. So what I mean by that is, right, maybe we need GPU data of Paint5D, and then we need like some other namespace, also Paint5D, right? But it clutters all of this up. So instead of that, what we're gonna do is if we look at our library chain, and we look at the top file, we'll notice that the library chain file itself, so this library chain file is basically the guts of, like, this thing here. This is a nice top-level summary, but the guts of how that library chain works is inside of this file. And you'll see, we have, different includes for including these different systems. So include file boy, right, corresponds to this, and then the include native keybox, the include keybox corresponds to this. And so this is very verbose and just very cluttered. But you'll notice that most of this is very consistent pattern-wise, and then all of a sudden we get to like this chunk right here for the frag bed, right? And frag bed has another folder and a whole bunch of other stuff that needs to be included with it. And so all the inconsistency is right here, but when we look at FragBed here, we're not breaking any consistencies in the higher level view. So I feel like we could have that same kind of pattern with the GPU data, where we're not going to call it, call this GPU data Paint5D. We're just going to call it Paint5D. And if the Paint5D needs like other files associated with it, we can kind of put them in here. So if we look at Paint5D now, Paint5D should be the last thing. And okay, this is just kind of verbose. We just have some commentary. I think it's fine to have that commentary. I'm not gonna break a sweat over it. This is just giving me an overview of like what I'm trying to do, and yeah, that's fine. And then it's the exact same verbose code all over again, except it's for the functions basically. So we got two sections, one that includes data, and then we include all the functions. So so we're building, so this build system here, all right, this is connected to libchan top, and then this file itself will make it so that we include all of the data files before we can include any of the function files. And that will prevent any type of superficial dependency loop problem from happening. So imagine you have class A, and class A references class B. Then you have class B, and class B references A. So you have a dependency loop where you can't declare them because they reference each other, right? I want to avoid problems like that. And one way to avoid problems like that is to realize that, well, class A doesn't really depend on B, and class B doesn't really depend on A. They just depend on each other's data. They don't really depend on the class. They actually depend on the data that the class is coupling together. But because the class tightly couples functions and data, you get these superficial dependency loops that could be easily fixed if you declared class A.data, class B.data, and then you can declare class A.functions, class B.functions, and now you don't have any dependency problems because class A functions might reference class B data or class A data, and so the functions might reference each other's data, but it doesn't matter because both of the sets of data for both classes were declared previously, if that makes sense. I don't know if I explained that well, but let's just keep going. Yeah, so anyways, looking at that, I think we need to fix some of this ugliness. But the first thing we want to do is just make sure we have documentation in place. We want to finish documenting GPU data Paint5D, and this is the function documentation. Let's look at the data documentation first. GPU data Paint5D has one variable. Okay, if we look at the function documentation, halt and init. Okay, yeah, so we're done there. We're done there, and do we have a summary as well? Yeah, and we have a summary, so we're good. We're good. We have we've kind of cleaned up everything, and we have a good idea of how everything should go together. So the next thing is, before we actually write more code, the very last thing I want to do is this GPU data Paint5D thing is an eyesore. So we're gonna just say Paint5D, previously known as, right? So we're gonna leave only this token here, and then everywhere else we see GPU data Paint5D. We're just gonna replace it with just Paint5D, and we're gonna be kind of careful at how we do it, because these namespaces here are annoying the hell out of me, and it's overly verbose, and it complicates things because you look at this and then you think it's an AAC2020 GPU data, but it's actually inside here. So denormalizing our namespaces like that is, we're just asking for trouble. I get why we did it, but I think it was, I think the consistency is more important than that. So we want to keep the code more consistent than what we've been doing. So let's make sure this runs. Let's try to compile. And if it compiles, we'll go ahead with our next refactor. And we might want to make a little checkpoint here where before we refactor that name, we might want to just make a note, just commit everything that we have, and just make a note that we have created all the documentation, right? So so we'll do a git bash here, and we'll do a git status, and we'll do a git add dot, and we'll do git status, git commit -am, wanted up to, documented up to, paint5D. Okay. And while we're at it, let's check GitHub really quick. Let's check GitHub and make sure that let's check our commit history, because let's see if we still have, did we miss any days? I hope we didn't miss any days. I'm trying to have like a, trying to keep my contribution graph. I'm trying to make sure I don't have any gaps here. Okay, yeah, so we don't have any gaps, we're good. I try to have more than one in a day, just because if I forget, if I'm on a weird schedule and I only have one commit, it could accidentally be consolidated on the border of like AM, PM. Like, imagine if you're trying to do one commit a day, but then you have an odd sleep schedule and you do, one commit at 11:59 p.m. and then the other one you do at like 12:01 a.m. or no, that would still work. But imagine that instead of doing that, you did your commit that should have been at 11:59 p.m. ends up rolling into the next day at 12:01 a.m., right? And then you have 2 commits on one day, but 0 commits on the other day. And now this graph will have holes in it, right? So no contributions, but 3 here. So it's very possible, and then 4 contributions here. So it's very possible that I was working on, code on this day, but some of this was like in the AMs here, and then maybe some of this was like also, right, like one of these commits could have been like right before the next day started, and this last commit could have been right after this day ended, and I could have actually been programming on that day, is what I mean, right? Now, probably not so much for this holy area over here, but I know I was trying to get pretty solid here, so I'm pretty sure that these are like little mistakes where I kind of fucked up. But I've been doing better. If we look at my previous contribution, right, I've been more sporadic. Now, this was because I was working on a patent library stuff, and this is like was only game project stuff. In the patent library stuff, I wasn't committing here, or I was only committing it to my local repo. So I know I was doing more commits, but they're not logged here. And here it looks like I was a little bit better, right, where we got a little bit more history, and then more history, right? So, but now you'll notice that this is more evened out, right? This was like all over the place, but we have some really dense areas. And a lot of these dense areas are actually probably like Node.js stuff, where we're using Heroku, and the build system is kind of linked to the version control, so you have to commit before you push up to the server, and that's why we have more changes, because you kind of have to commit every time you make some type of code change. Whereas here, I'm only committing after I'm completely done. So I guarantee like this 54, 61, that's probably Node.js stuff. Those little blips. And then if it's just solid like this, where there's not many differences between there's not many contributions, it's probably me doing like my the kind of code that I'm working on right now. So, anyways, I just want to take a look at that. So let's do a git status, and then we'll close this. Clear git status. Okay, nothing to commit. We're good. So let's refactor GPU Paint5D, right? So let's, first of all, we're going to take this and we're going to find in files, and we're just going to do find all. We're going to see what kind of stuff we have and what do we really care about. So the .d file, the pix name, the macros, there's a lot of places where we want to, well, even in here. So let's start from the, do you want to start from the top of the list or the bottom of the list? Let's just start at the top, I guess. And let's just open this up. And we're just going to remove this thing that says Paint5D, and we're just going to change that, right? And that's all we got to do there. Or actually, no, we still have to do this right here is now just Paint5D. So Paint5D is an instance of GPU data, right? So that's good. Now let's go over here and see what we have. So once again, we're just going to rename this to Paint5D. And now everywhere where we see GPU Paint5D like this, we're going to replace that private namespace with just Paint5D, right? So, find next. Replace. We want to actually match case here. Then we're gonna do uppercase and do one more pass. Okay, and we'll save that. And we are in the paint5d.f, so let's move on to paint5d.d. And we'll do the same exact thing we were doing. This is just a comment, but still, let's refactor it. Find next. We will replace. And I guess that was supposed to be lined up with that, I think, so we'll put that back like that. Then we'll copy these, look for the lowercase versions. Okay, so we're good there. And this is the .d file. Let's look at the .top file. So we can keep that comment for now, I think. But there's still other stuff here, right? So, we're going to change the actual code. But then, as far as this is a pattern breaker, we'll just, we should probably, like, clean that up later. But let's just keep those comments for now. And then we will look at what we have next. So this is F macros. So in our library chain, we're going to look for anywhere we see GPU data Paint5D, and we're just going to replace it with just Paint5D rather than this include. Oh, and we're going to also have to rename the file, right? So let's replace. Oh, actually, do not use. Oh, this says do not use. Do not use. So we must have already had, we're already doing include Paint5D like this. Yeah. So that's fine like that. Okay, so let's take a little bit more of a look at here. So why do we have include Paint5D data? Okay, we have Paint5D data, but do we have the .f for functions? Oh, okay, yeah. So this is where we screwed up. So so this include needs to be like that. So we'll worry about fixing the pattern breaker comments later. Yeah, I don't want to do it that way anyways, so that's good. Okay, and if we look for just Paint5D, and we try to match the whole word, we're going to see the data file. And this comment is going to be wrong eventually, right? But we'll fix that around later. One thing at a time. So let's look at this. So let's look for these. And let's yeah, so now we have this like legacy of bad shit, right? We'll change these. We'll keep this because this is actually a hashtag comment in our documentation, so we'll keep that. Yeah, we'll keep those. And then we'll look for the, if we match case, do we find anything that's lowercase, or is that it? That's it, okay. So that is GPUData.d. And then we have some stuff here. That comment's kind of fine. That comment's fine. That is... That's old, but whatever. It's just commentary, so we'll keep it. Okay, so now let's look at the data file, and let's clean up the data file. Let's clean up all of our documentation files. So we're going to remove this GPU data from here, and we're going to remove this here. Alright, we're just gonna remove these inconsistencies. Okay, and so that's the data file. Let's look at what else we have. This is just a mess. Function file, same deal. Let's remove the GPU data prefix. And that's functions. Let's look at the H hashtag stuff. So for the hashtag stuff, we're not going to remove it just because it is that's kind of like grandfathered in kind of stuff. And this is summary. Why are we... Oh, this is an index. Oh, we were building an index, weren't we? I mean, an index is fine. I guess we could do that. So, let's fix this, though. Let's remove that. Yeah, I'm fine with having an index. That's okay. So let's take all this and let's just do a clipboard stack start. And we will just say, we'll take this. Oh, wait, we'll not do it in that order. That'll lead to some problems. So let's do it again. So CS start. And let's actually take things in the order they appear. So the index, we're just going to take all of the different names of all the different subsystems that are part of this project, and we will copy them to our clipboard stack to create a simple index of everything that's in here, right? And we'll just have that index at the very top. So CS dump, and we'll dump our clipboard stack, and now we have like this index of everything that's in here. Are we missing something? I don't know. But now we have a in-order summary of everything. But yeah, just calling that Paint5D I think is better. Okay, so now the next thing is, have we broken anything? So we're going to close all but this. And sure, let's reload that. Yeah, let's reload that. And let's close everything. Let's just keep this open. And let's give this another run, because now there is definitely the probability of me having broken something. So, Paint5D. Okay, so that's pretty simple. I just forgot to do that. So over here, right, when we're trying to search for Paint5D and we type Paint5D, we can't find it because it has this prefix. So we're going to remove that prefix and just call it Paint5D. And then over here, once again, we're also going to remove that prefix and just call it Paint5D, right? Okay, now that we've removed that, we can go back and try to build. And that would... Hopefully that's the only problem we have. Hopefully I didn't make any other screw-ups. AAC2020 Paint5D DAT undeclared.
Yeah.
Yeah?
After dinner, we're gonna do s'mores outside.
No.
No?
I'm not eating any sugar.
I see, so you're a coward.
Yeah.
That's fair enough.
Okay. Okay, so, first thing I see here is that this is wrong. The namespace, if it is a private namespace, this would be all lowercase. If it is a public namespace, this would be all capital. So when we refactored, we must have screwed up there somehow. So let's see, paint5d.f17. Let's just go into there and see what we kind of screwed up. And fix that. So paint5d.f. No, we don't want to create it. So we renamed it, so we got to like reopen it. This is what I mean about there's no such thing as a trivial refactor, right? You can make changes to something and you think you're not changing any of the functionality, and then boom, you get fucked over because you did actually change some functionality. And was it actually in the F file? Oh, paint5d halt, yeah, and then this dat is wrong. So if we go, let's open the data file. So if we go over here and we open the data file, that's an improper namespace. I can already tell. And so should it be public? Yeah, it should be public. It's going to be used by other things. Now, was that my original intention, or did I lose that in a refactor? No, I'm pretty sure this was supposed to be public. So we'll do paint 5D like that, and then we'll try to give this another run, and hopefully that was it. Hopefully there's no more stupid little problems from trying to refactor everything. So it looks like that was it. Looks like that was the only mistake I made. But that's why, you know, it's nerve-wracking to refactor things, and I like to go very slowly. Just take my time, make sure that I'm doing things correctly. So that looks good to me. I think, you know, we've gotten rid of that inconsistency. So now, when we're looking at including things, paint5d is actually just paint5d rather than GPU data paint5d. We can keep this commentary just to help remember, you know, where paint5d is kind of how it's kind of tightly coupled with the GPU data. That's fine. But now we're at a good point where we can actually start adding some more stuff. But we did have those vital to-dos where we wanted to do some refactorings. So I think we should clean those up as well, right? Let's just try to get all of the boring cleanup stuff out of the way right now. And then we can move on to... oh, I see. We can move on to addressing other issues once we've hit a nice stable point where we've got our bearings again, we kind of know where we are, and everything's kind of cleaned up. So the first thing we're going to do is we're going to commit these changes and say git status git add dot git commit -am GPU data paint5d has been refactored to let's make sure I don't have an R2. So I'm gonna make a note and see if I use R2 for anything. So R2 means oh, I already have it as renamed to, so we're good. R2 means. Yep, so R2 stands for rename to, not refactor to. But that doesn't change the meaning of this comment. So I have a documentation for what my shorthand means. So R2 stands for rename to, and so we can just keep it like that, and that's concise enough for me. Git push GitHub master. Okay. So the next part is, even though this works, so one more sanity check before we break this. Okay, we are going to take this code and we're going to turn the vital to-dos back on, which is going to break the code, but it's going to address like what needs to be changed, and we can kind of like start fixing up the code in the places that need addressing right away, and that'll also give us will also tell us what we need to do, right? And it'll give us a nice little task list as well. So let's we're gonna go into the main file, into the main configuration file, and right here we have the crash on vital to-dos. We're gonna turn that back on, and then we can just kind of run it again and kind of see like, okay, what's our problem? Where do we need to fix stuff? So get rid of these fucking callbacks. So let's take that. We can copy it. We see it's in GINAWIN, but the cool thing is we can eliminate some of the thought process. We can just be like, oh, here's a unique message, close it, open something up, Control H, find in files, right? And just find it, right? We don't gotta, like, I feel like that's just easier for me. Maybe I'm just being overly convoluted. And we can see that we have some callbacks that we want to get rid of, and it's all this stuff. Like, I just want to get rid of this stuff. And so I think that we already got rid of this code. And the first way to try to refactor this out is we can just comment this out and just see where the compiler errors kind of lead us, right? So what we're going to do is we're going to comment this out, but we're also going to comment out the callbacks, right? The callbacks that we're trying to get rid of right here. We're going to just comment them all out because this is just stuff that I want to get rid of, right? I don't want this in the code base anymore because we have the iKey box, iMouse box to allow us to listen for the keys without having to use callbacks, because remember, memory coherency, we want to make sure we control what threads our code executes on, and if we use a callback, then if we use a callback for these things and the callbacks execute game code, then the game code is going to end up executing on the window thread. And if we have a separate thread where we don't want those functions to be executing on the Windows thread, well, then we just wrecked that, right? And so now we're going to have just memory coherency issues all over the place. So yeah, we'll just comment this out, and then we'll just see if the code compiles, right? And if the code compiles, then we'll be like, oh, well, I guess we fixed the problem and we can move on. And so we see that unknown type names. So in GINAWIN.f, right? So in 68. So let's go to 68. We probably have some like old code for supporting these callbacks. And what we're going to do is we're just going to rip those callbacks out. Where this was taken from some old library code, and you know, maybe some of my other projects use callbacks, but because we've cut all of this, since we cut and pasted our library code, we're free to make changes to the sub-library and tailor the sub-library to this project and not worry about the needs of any other project. So in here it was like 68, right? So on window resize set callback. So what we're gonna do is we probably have a whole bunch of callbacks, right? So it looks like we already commented this out, but we have this is still a callback, right? So we're going to not do this, right? We're gonna take all this and we are going to window resize callback and on mouse move. So we're gonna just take these and we're just gonna go bam bam, and we're gonna eventually delete all this stuff, but we just want to comment it out for now. But it definitely looks like we were in the middle of getting rid of these callbacks. Okay, so we've got it. So let's run this again. And the one thing we want to make sure that still works after we get rid of this is we want to make sure that that the shader correctly adjusts when we resize the screen. So on Moose 521. Okay. So in 521, what do we have, and how can we manage it? So 521 is just like this little stub where we were like getting rid of the callback code, right? So we were in the middle of getting rid of callbacks and trying to do things using the iMouse box. Like, yeah, iMouse box is right here. So we were in the middle of that already. It's just that we haven't, some of this stuff is still kind of stubbed in there. And we just want to do things in a very incremental fashion so that we can just take our time and kind of whittle away at it. So 665, we want to whittle away at it until it's out of there. And we want to do it in 2 steps. The first step is just to comment it out. And then once we've refactored everything by commenting the things out, then later we'll go ahead and delete them. So 665, we see we kind of do this, and else. Yeah, so this is a big note about not using callbacks. So this is, I think, a hackish intermediary in the middle of kind of getting rid of those callbacks. A little bit too elaborate, but yeah, that's fine. So, because originally we'd have like a warning, GINAWIN has no resize callback, right? And that was for when this library was a like reusable library for that other projects could share. But now we are tailoring our use case to this specific project, so we're using GINAWIN as a sub-library. So we can get rid of anything that might have a more generic use that's not used specifically for our game project. Okay, so let's try this and see if we can once again get this to run. Okay, so we might actually just crash on another vital to do. So I see vital to do, whatever, blah, blah, blah. So the next thing we're going to do is we're going to go back into our configuration. And we are going to stop crashing on vital to-dos. And we're just going to make sure that the current vital to-do that we did was a completely successful refactor, and the code still is functioning how we think it should be functioning. And we know that we just that the resize callbacks and the mouse position are things that we need to address. So it looks like iMouse is still working, so we don't need a callback for iMouse. We deleted all those iMouse callbacks, but that's still working. The keys are still working, right? When I press keys, there's no keyboard callback. There's absolutely no keyboard callback, but we still have keyboard responsiveness because of the way we structured our code, right? We're trying to eliminate those callbacks and make the code much more simpler and easy to follow, right? So sometimes the simplest solution is not actually the most obvious solution. Because the most obvious solution would just be use callbacks for the keys, right? Create like a callback keyboard handler callback, but yeah, it's much more simpler to do it the way I'm doing it. It makes the code easier to follow. Now the next thing we want to check is hoping that if we resize this, that everything will change correctly. Yeah, so that resizes correctly. One thing I am kind of, where did you go? One thing I am kind of worried about is if I full screen this, if it full screens correctly, and that looks like it actually full screens correctly. There's other code that does not full screen correctly. It's weird that I don't even have a border. Oh, so I probably decided that if I full screen it, I don't want a border, but I want to keep the address, this bar here, because, you know, sometimes people don't know how to exit out of a program if, or exit out of full screen. So I'm like, you know what? This here isn't much extra space. Let's just keep that there. Yeah, this is some stuff. But we can get rid of the border. I kind of like it like this, where we still have the window, you know? Other people might not like it like that, but I think that's fine. So yeah, so I'm good with that. Oh, we can look at this in full screen. That's some pretty cool stuff. So this is like ray marching. I didn't write this. This is just stolen off of Shader Toy because I wanted to see, can I actually run this kind of cool, awesome stuff in my code project? And the answer is yes. So I know that I'm in a good point where I can start working on my shader code in here. Let's do one more thing. So let's incrementally commit here. So let's do a git bash here, and git commit dash am, or actually git commit dash, or sorry, git add dot, and then git commit dash am, commented out window callbacks. Okay, and git push GitHub. So now we're gonna do one more pass, and we're just gonna delete those callbacks. Okay. So in GINAWIN+D, right, we have all this stuff, and we don't care. We just want to get rid of these, right? We have this, get rid of these fucking callbacks. That is exactly what we're doing. So let's, all this commented out stuff, this conceptual library members bullshit, yeah, let's not do that. That was bad. It was bad, and now we have gotten rid of that horrible mistake. You know, this code still looks kind of like shit, but at least we got rid of some cruft, and we can kind of move on with our life. Now, did we have this commented out somewhere else as well? Yes, in the functions, also, we commented out these big blocks here. So now that we've commented them out, we'll do our second pass where we can kind of commit to that, and we can remove it. And removed, let's try to make a mutex semaphores and fences. So this was kind of a historical note, so so we can say, tried to make a game without, a game without mutexes. So, multi-threading is going to be a pain in the ass, and lead to just weird, hard to debug things. So it'd be better if we just, I think Doom ties a lot of their game logic to the frame rate, and that is probably because they're avoiding problems that can occur with multi-threading. That is why I guess they do it that way. They're just trying to keep everything dead simple. And I want to keep everything dead simple as well. Oh, and by the way, the only game I play is Doom, and that's probably why whenever I'm referencing the way code is written, I'm referencing, like, John Carmack and John Romero. Not to say that I write my code like they do, right? I have a lot of batshit insane ways I write code. But let's go into our hashtag documentation, and let's just take that little comment, and, you know, because I think that it is important to note. Also, let's remove the multi-line kind of comment style here and put, like, single-line comment stuff. And it's fine if we just paste it in there like that, and then we'll take this game without mutexes here, and we'll put this hashtag comment here, right? And this is just more, more historical stuff. You know, a lot of this stuff is probably going to be ignored, But the idea is that it's there and you can find it if you need to find it, right? It's kind of buried in here, but it's there if you need to find it, right? The indentation, whatever, I don't care too much. So game without mutexes. I feel like there's probably some other commented out stuff. Oh, this is okay, so this is also the code we commented out. Oh boy, I hope I didn't accidentally take a bracket with me while I was deleting stuff. Well, we'll find out pretty soon if we forgot a bracket. So let's try to rerun this really quick, because make sure we didn't accidentally delete a bracket, right? We'll know right away if we accidentally delete a bracket. So it's running, so deleting a bracket would be a compilation error, so we wouldn't even be able to get this far. So I'm good. I think we're safe. Let's keep on going. So oh, there's another large swath of stuff. And on mouse move, whatever bullshit, blah blah blah. So all these callbacks, right? And so the callbacks seem simple, but then you need to create like these signatures for the callback, and you need to create function pointer types for the callback. And so it's a lot of extra code as well. So it's like not as simple as you think it would be, right? It's a lot of just extra bloat. Right, so this is a lot of effort. This is a lot of extra stuff to type. And so I think the iKeybox and iMouseBox kind of thing that I'm doing is a lot better. I think the way they do it in GLFW or SFML is they have like a poll events kind of function, and that would also be a good idea. But yeah, okay, let's just delete that out of there. And now let's just make sure, do we have any like big sections of commented out code? Like we scroll through here really quick. Actually we do, we have this thing. What is this? Yeah, this is when I was using mutexes and whatnot, and let's see if we can find anything else that says put render tick function, or if this is the only case, right? Like, if this is the only case, then we're just gonna... I assume this is probably from a previous library. Yeah, let's just delete this and just forget about it. Let's pretend that it just never existed. Yeah, let's just pretend it never existed. We're not even gonna tuck it away in our hashtag comments. We're just gonna pretend that code didn't even exist. And the only trace of it will be in these recordings. So to do this needs to be rewritten, so the only difference between the threaded and non-threaded version is where our infinite... so I think we've already been kind of working on... I've already kind of worked on that a little bit, but we'll double check that really quick. But first, let's make sure this still runs, make sure I didn't break anything, and then we're going to commit this as well. Okay, so yeah, yeah, duck. Removed commented out code. GINAWIN callbacks. GINAWIN callbacks gone, removed commented out code. That's a little bit verbose, but that's kind of like, I just want to note what I did. I know a lot of people say that comments should only be why you did what you did and not what you did. I disagree with that. Okay, so the next thing we can do is we want to figure out, oh, well, where do you want to go next, right? And to figure that out, we can go back to our buildy scripty thingy, right? We can go back to the main C11 file, and we can just put this back on, right? And then we're going to crash something else. I know we are. And then we'll know what the next task is, right? And eventually we'll get to something that's actually interesting. But, the thing is, not everything with writing a game is fun. And, you need to be able to... maintain concentration, or be able to work through the boring parts to get to the fun parts, right? So let's find all right here and see what we got. And so this is where it's coming from. And GPU data test, CPU and GPU. This will require setting an OpenGL texture using struct. So this is... Yeah, I don't know if I want to do that. So this would be good to give us some sanity of mind. It's a way to, like, check the code, but if we write all the code correctly, we will never need to do this, right? We just want to test that the CPU and GPU code, that the variable, that the data we put onto the GPU matches the array of data that we have on the CPU, and we want to make sure that that stuff is always synced. So we want some way to test that syncing ability. And so I do think that this could be an important test. But I'm going to say that rather than a vital to do, I think it should be a maybe to do. Like M-A-Y-B-E, maybe to do, right? So I think this is priority-wise. I think it was a... Priority-wise, this is getting in the way of me actually getting a code up and running. And I've never actually written code like this before. I was just very careful, and I had structs that kind of managed the synchronization. So we will ignore this one for now, and we'll just call this one maybe to do like that. And let's just add another configuration in here. So let's do so over here we'll do like define AAC2020 crash on maybe to do, and we'll make that a 0. And it looks like we have this include. Now, is this really necessary to have this like vital to do here? I think this is just kind of clutter. It's helpful, but I don't really think we need to... This is the first file we open. I don't think we need to... I don't know. I could be wrong, because I kind of get why it's here, and... I'm going to take that, and I'm going to put it in... I'm going to put that in the libchan top. So if we go into the libchan, I can kind of see why extracted from AAC 2020.c11, right? I don't know if this is the best place to put this, but I'm going to just make a note of, it was extracted from here, so this include happens before these includes. But I just feel like I'm skeptical about where this should be. So we'll kind of make a note of where it's extracted from, and then we'll also do this. We're going to do lib stable AAC2020 maybe to do. You know, why not? Let's keep the pattern of vital to do, maybe to do. And then let's open up the stable code, and we see this is just like we're taking functions, and we're naming all these files based on these functions. And the idea of these stable to do is they're just like miscellaneous functions that they're not going to change. They're kind of like they're these one-off functions where maybe they're dead simple, or maybe I've just used them so much that their functionality is never going to change. I mean, that's making a bold bet saying that it's stable and it's never going to change, but I'm going to make that bet with some of this code. So with this, we need to just copy all of this code, and we're going to cut, paste, and just change things around. So all it is instead of vital to do, it's going to be a maybe to do. So everywhere we see vital, we'll just replace that with maybe, and that's all we need to do. So maybe to do, and maybe to do, and maybe to do. And so this helps us kind of prioritize things, and we can still crash on maybe to do's if we want to. Let's do, I don't know, not 222. Let's do something else, like, I don't know, 1, 2, 3, I don't know. Technically, it needs to be less than 255. Let's do 42, yes. Let's do the thing that those programmer nerds always do, and put 42 in some random spot. Even though I haven't read the book, but I don't know, the movie's kind of like clever and creative and interesting, but it doesn't grab, I watched like 3/4 of the movie. I watched it pretty far in, but I never finished it. So maybe to do. So AAC 2020 maybe to do. AAC 2020 maybe to do. But I do get why programmers would like it, right? Because first of all, it's right. They talk about a giant God computer, right? And the idea of the answer to life being 42 because they didn't specify the format they wanted the answer in, and that's you know, I do think that's kind of like I do think that's funny. It's just that I don't think it's whole movie worth of funny. It's like here it wasn't computers perfect AI. Hold on, I'm gonna look at something up really quick. Computers perfect AI. You mean AI perfects AI? No, it wasn't AI perfects AI either. What was it? Hold on. Okay, hold on. Let me just go over to my other monitor so you see what I'm doing. Yeah, so I'm just over here on the left here, and I'm going to get rid of these. I'm just doing some shortcut maintenance here because it was relevant to the random thought I had. So let's go back to that kind of random thought I had. Okay, cool. So, the top of my shortcuts here, computers perfect AI. What I want is AI perfects itself. Date 2020 12:05. Okay, so if we go search up here and we do AI perfects itself, we actually may need to reload our shortcuts. I'm guessing since I did this, I didn't reload my shortcuts. But let's just look at this, because... So when I think of, like, Hitchhiker's Guide to the Galaxy, right, I think the 42 is a funny joke. I just don't know if it's good enough for a whole movie, right? Like this little comic... Oh, you can't see that. This little comic is kind of funny. I don't know if it's funny enough for, like, a whole feature-length film, though, right? So same thing with Hitchhiker's Guide to the Galaxy. Okay, now you can dox me and swap my house now. Okay, so we've kind of made this kind of hacky refactor where we have this, like, maybe to do function, and in our C11 code, right, we removed that import, or not that import, but the include for the library code for this. But now we just replaced it with this, so we have kind of, I think we have more usefulness in here, and we didn't actually increase the size of this file at all. So I kind of like that. So let's take this and actually let's do everything as zeros first, and just make sure that we can get everything rerunning. Lib stable AAC2020 vital to do no such file or directory. Okay, so that makes sense. That's because when we move things around, the relative location of some of that stuff has changed. So let's look at our libchan top, and now it doesn't have to be in lib anymore, right? It can be in libchan top is within the lib folder already, so we just need a // right? And if we do that, we should have fixed that refactoring problem. Yeah, so now we're actually running. Okay, yeah, so everything looks good. Right. Okay, we're good. Close that. And let's go back here, and let's close all but this, and let's crash on vital to do and see where we are now, and see, like, where are we on our list of things to do. Okay, so nice. So now the maybe to do is showing up, but the maybe to do is not what's crashing us anymore, because we said not to crash on a maybe to do. But then we have a vital to do, and we see AAC2020 GPU data init instance. Okay, so let's go take a look at that, because now I think we're actually in the interesting code. So let's close this, and actually we got to search for where that is happening, right? So find in files and find all. It's probably actually in the init instance function. It's probably like a empty kind of yeah, it's an empty kind of, right? It's an empty function, right? It's like we got to start doing this, and we got to figure out how we're going to set that all up. And so yeah, so where we are now at the point where we're at the point where we can start getting things kind of interesting, right? So we want to do like a texture upload. We want to initialize the array of data. We want to upload it to the GPU. We want to sync it all, and then we're good. And then maybe we'll have like a we'll figure out things from there. But yeah, we just want to get that data up onto the GPU so that we can have a shader that can use that information. And then after we do all that work of pushing it up, like, we're going to need some confirmation that we can actually use that. And the way we'll do that is we'll use our Paint5D shader will be used for that. And so we'll probably need like another file for like Paint5D shader code. It's going to be my experience is we actually don't want to load the shader from an external file. And the reason for that is we want to keep to the single payload executable where all the shader code is kind of like in the same, is in one file, all the shader code I want inside the executable. Now, how are we going to do that? Because multi-line strings, they usually need to be like wrapped. Yeah, I don't know. We'll figure it out as we go. But yeah, so we have a good point at which we know what needs to be done next, right? So let me move this down here. And that was like 2 hours of refactoring. That's a decent chunk. So I think we'll stop here. But now we're at a good point where we like know what needs to be done next. So let's commit this, right? So let's get bash here. So we're not committing in a broken state. Yes, it crashes when we start it, but the code itself isn't really broken in the sense that it would be a work to recover, right? We don't want to commit stuff in that is so broken that we can't. Well, in general, we don't want to commit broken code. Our code is intentionally crashing because we have that flag set, and that might be an exception to my rule, maybe. But the idea is if you commit broken code and then you come back to that code a month later, you're not going to be able to fix the project. You've basically lost your project by then. So we're going to do a git status, git add dot, git commit -am, and to do initialize GPU data. Okay. Yeah, but I'm gonna stop recording for now. I'm gonna I don't know when I'll be back, but I need a little bit of a break. And so I'm just gonna stop recording and then start up the recording again later. Yeah, so I'll be back later. Maybe 30 minutes. I'd say give me 30 minutes to an hour before I'm back. So it's 8. Yeah. All right, later.